Today is May 29th, 2025, and I just did a run simulation on LabVIEW for a humidity and temperature with the DHT22 sensor. The Arduino code is within the library. Here, defining the pin, DHT library, ball rate, then delaying, then identifying the floats, then identify the separation. With that plugged into the file that I created for actual project, named the file. This monitors the, it's not running yet, but I wanted to give a brief explanation of what this is. This big old gray box is a while loop. I did some other finicky stuff to try something new, a new monitoring system generally, but I came with some issues. So when I do another certificate, I'll do that too. So this is a visitor serial. This starts and initiates everything. You need to identify the conditions. Serial port is your identified COM port that you're connecting to. This coincidentally has, so click this, make sure it's connected. For live data, this right here is the live data. And you might ask yourself, what is the difference between a DHT11 and DH22? A DH22 is a more accurate version rather than a DHT11. There's more specifics, but I'm not going to cover that. This identifies the resource name. This identifies the baud rate, which identified in Arduino code, which is 9600 bytes. This is a constant here for separation of the two values. Then the Visa, this is the always, so there's one thing that you need to know when you're starting LabVIEW that I knew. You always have to have a Visa serial, Visa read, or if the LabVIEW is sending data, you use a Visa write, which right now I don't have it because we're receiving data. We just need to read it from the Arduino Uno. Then we have a list value, which is a string indicator, indicating values from the Arduino. Placing the values here, splitting into a match pattern. Match pattern converts the string into a numerical value towards the graph. Doing the same process here for a temperature thermometer, which is displayed here. And this is the delaying factor. The delaying, I can show in a minute, this is delayed, for about 1000 milliseconds. This keeps this value for 1000 milliseconds, then updates. After 1000 milliseconds, then updates. This is a live value over time per second. So is this, the temperature thermometer. This is a trim, it's a trim, let me see. It's a trim white space. What it does is clears out, it smoothens the bytes and transitioning, so it does not get, coincidentally it's self-explanatory. This is the thermometer indicator here. This is the waveform chart here, and it all displays here. This is the block diagram, and this is the front panel displayed here, differential. This is a toolbar here. You get these values here, and then it's best to use the search bar, or if you need more specifics, use a space or control space, and you can look a quick drop. Here we need to have this stop. This stop identifies here. You stop it, stop the loop, meanwhile loop, and this closes, the Visa closes the loop. So make sure it's running again and running this simulation again. So here's a little trial run. That's the values for humidity and temperature. So let's test it out. So my computer is put under my bed, or my computer, because it's kind of hot. So we're going to see a spike. Let's put it under there. See, it's rising and the temperature's rising. Let's put it for 5 to 10 more seconds. Alrighty, that's good. Now we take it out and wait for it to decline. Should be good now. Now it's cooling. The DHT, I understand right here, is going up. What I think is what's happening is my connector here, which that's the easy fix. So right now it needs to decrease and cool. It is cooling down now. It is cooling down. The humidity has dropped. It went from a jump drop, but that's not common for that. There you go.